Hello everyone, welcome to another Webinar Wednesday. I'm your host Benjamin Taylor, and this week's topic is involving your testing team during development. How do you involve your testing team? Why should you? And how do we even do it in multiple scenarios? So, without much further ado, let us get started. So, first of all though, what is this webinar? Well, I want to discuss why testers should actually be involved during the development process and during the development phase of software that we're building. Going to be a bit of an overview and sort of look at some old-fashioned ways of thinking regarding software development, but it's important to sort of understand where we're coming from and why testers are important in the first place. And once we know that testers are important and we should bring them in as part of a development phase, then how do we actually involve them during the development? So what does it mean to actually have good testers? Are they just sitting to the side, not doing anything? Well, no, they're not. So we're going to bring that up and discuss that. And finally, just to end out this webinar, I just want to have a look at a couple different software development life cycles and how we can think about testers being brought into each one. Just so you have some practical understanding that's a bit more concrete, rather than just theory of, oh, bring in the testers. No, let's actually discuss properly on what we can do. So, to start first on our webinar today, why should testers be involved during development? Well, I think if we want to ask why they should be part of development, then we need to look at this sort of old way of thinking of how development and testing worked. Because in theory, the old way of thinking was that developers make the software. Clients write their requirements, goes through managers, developers make the software, and then the testers go on to test that it ensure it works. Testers come back saying, yay, software works. Developers get to go home, everyone gets paid, it's a good old time. However, we know that in reality, things are sadly often quite different. Because in reality, the developers, if they're not managed correctly, and by managed I mean normally with tester feedback, developers will make something that's like the software they were supposed to. It may do all the features that the client has requested. It may look like how the client has requested, but it's only like what they've requested. And instead, testers will report that the software isn't actually what the client needs or what they want, and something needs to be fixed. Either there's defects that have been found that are detrimental to the use of the software, or just flat out features have been missing. And this is where testers shine. Testers help find these aspects. Because if we just leave it to developers, we're not always going to get there just in case. But I'm talking a lot about software. And of course, software development in general. That's what we're here for. But software development is just more than software by itself, though. As testers do more than just test software. Testers exist and work to ensure that all parts of development meet the client's expectations. We want to ensure that all aspects of what the client wants in the software are being met. This means that any inconsistencies or uncertainties will often be spotted earlier thanks to testers. They are the ones who are going to look at those requirement documentation and actually try to understand as best they can what's the client getting at. And if they're uncertain about what the client's actually wanting, then they're the ones who will normally either request more information or have someone else request more information on what's missing. Testers are also really good, of course, for developers, as they help give developers benchmarks to reach on what is actually acceptable for the software that we're looking at. So testers help give us that ground level, that quality assurance and quality control in our software and our projects. Because if we didn't have testers, would be having some issues. Namely, we might find that crucial required features may be missing in the final project. Developer may have thought they implemented something like that, but it turns out it doesn't meet what the client actually needs. The client may also not be exactly clear when they talk about different things, so we may have, without testers, untested assumptions that have likely been made about a product. Of course, in a perfect world, the clients would always be able to tell us exactly what they want, and we'd just make exactly what the client wants. But we know that isn't the case. And if a client could say exactly what they want, then they're basically coding themselves. So we know this isn't the case. We know that there will be assumptions to some degree. And while assumptions are okay, they should be tested. Either literally going to the client and saying, hey, we weren't sure about this aspect of the design. We've interpreted it as this way. Is that correct? Or having a discussion between the developers and testers and seeing what is the more likely outcome or intention behind these assumptions. And as well, without testers, developers could unfortunately fall into this sort of good enough mindset of, yeah, I made this feature, I think it's good enough. I think it works, it functions as it's supposed to. It's good. But does the feature actually work? Does it possibly just randomly crash? Are there some race conditions which could be hit with multiple users? Can it even withstand multiple users at the same time? That's something that a developer may not think about immediately, but we as testers need to think about from the very beginning. So hopefully you can understand that testers really should be involved with development, because if you don't bring the testers in until the very end of a project, you're going to have all the developers standing around saying, yep, I'm proud of this, it did well. The testers are going to come back and say, actually, there's a whole bunch of issues. You want this out in next month? No, it's going to take like another 2 months to fix up these issues, clear up these changes, and especially if something in the requirements is incorrect, oh, that's going to take quite some time to get sorted. So, bring in developers early. But how do we actually do that? How do we involve the testing team in the development process? Well, one of the ways we can do that is with the shift left approach. And I'd say shifting left is just the easiest method for bringing in the testing team. In a standard software development lifecycle, as we'll see later, we normally leave testing till the very end. Shifting left says, hey, hold up, let's not wait until the very end. Let's instead bring testing in earlier than we would normally think to do so. In a model like waterfall, where we test at the very end, maybe we should bring testing during the development phase. But shift left doesn't just stop there, because shift left says, well, actually, the earlier the better. Don't just bring them in for the development phase, bring them in for the planning, bring them in for the requirements. The sooner and earlier we can bring the testing team into a project, the better it will be overall. Now, of course, there are limitations, and money may be a concern. But I would say, what costs more? Does it cost more to have a team of testers running a longer project from beginning to end and still fit within a time frame? Or does it cost more to have the whole team, the whole project running for an extra few months or weeks or months to fix up issues that were originally found because the testers weren't there from the beginning? Personally, I would think that bringing the testers in early does actually save you money in the long run. But hey, that's dependent on the team, dependent on the project. But ideally, shift left, bring the testers in nice and early. How else can we do so? Well, we can also look at thinking of the whole team approach. This is an approach of software development and project management in which anyone in the team can pick up any team task that exists. This means that we don't as much have a fixed developer role and a fixed tester role. Instead, anyone can be a developer, anyone can be a tester, and importantly, everyone becomes responsible for quality. Now, there may be a couple issues with this. Not every tester and developer will have the exact same skill set. But we should really try, and I think one of the great ideas is to have this openness where anyone can take on these responsibilities. We'll be talking about this more in the next slide too, but just as an idea of bringing the whole team together, losing the titles, and just working as a group. Of course, I'd say the whole team approach does work best if everyone is sharing the same sort of physical space, but I know this isn't always possible, especially in today's interconnected world with like what we're doing right now, live streaming and chatting. There's always going to be situations in which you can't fit everyone together in the same office space, and that's perfectly fine. But ideally, we do try for that, as it will help build cohesion between the whole team. And in the whole team, everyone collaborates, everyone communicates together. Titles, a thing of the past. Instead, we all work together for the greater good so that we are all responsible for quality. Sounds good, right? And lastly, if we don't want to shift left, if we don't want to sort of think about the whole team, then honestly, I'd just say bring testers into the team. And what I mean by this is very simply make testers an actual part of the development team. It's really straightforward. It sounds really simple, and it is. But I mean, actually have the testers become some part of developers. Of course, very important to know if you have the testers be developers, and of course not every tester wants to be a developer. The testers themselves can also develop, but we should try and keep some degree of independence between what someone's developed and what they've tested. So, meaning a developer shouldn't test their own product because that can cause issues. Of course, they should test to a small degree to ensure that it works, to ensure that it's correct to their understanding. But also, we should try and make sure that instead they pass it off to someone else who can test. And this is really good, actually, if we're looking at someone who is a skilled developer, really skillful, but isn't a great tester, and a really great tester, but not a skilled developer. In this situation, the skilled developer can get the more complex and demanding programming tasks, whilst the tester can also test those complex and demanding tasks. It plays their skill sets. Meanwhile, the tester can work on the more straightforward processes that need to be developed, and the main developer can instead look at just quickly testing those processes, being familiar with them as they are. It's all this shared skilling, this upskilling that really matters and really helps project teams out. So we should always try and play to the strengths that we have. We don't want a tester busy with development work the whole time, because that's not their strong suit and that's a waste of their talents. But alternatively, we don't want them just sitting by without much to do, because the developer has to work on this really easy thing too. So play to the strengths and manage accordingly. And I did talk about independence in terms of not letting the same person test what they have developed. And when I talk about independence, it's sort of that separation between the development and testing on a personal level and organizational level. But I'd say if we bring testers into the team, we want to have low independence on projects where possible. We want there to be sort of this low independence where developers and testers work together. They're working sort of side by side, and they can check quickly, check accordingly, and make sure things are progressing as they should. Of course, for, I'd say, safety critical systems and the like, we may want a bit more independence, and especially to test those kind of assumptions. And even then, in just software development in general, it's really good to have multiple layers of independence, of dependence in testing. But I think right now, let's primarily focus on just keeping things simple, keeping things together. So, with that said, let us move on to the next part, in which we're going to look at how we can look at the different methods of software development and give some examples on how we can bring in testers into it. First up, though, the waterfall method, or waterfall methodology. Waterfall methodology, for those who may not be a little out of date on waterfall, as I would expect for the most part, most people have moved away from it. Waterfall is very rigid and follows a strict sequence of requirements gathering, design, implementation, verification, and finally maintenance. There may be some changes depending on which exact model you want, but that's the general idea. And traditionally, waterfall brings in testing near the end of the whole process in the verification stage. So everything's been made, requirements have been gathered, designs have been settled, the actual implementation, the coding's been done. All right, let's actually test it now that we've coded everything. But as we sort of talked about earlier, looking at the old ways of software development, this may mean that actually verification can fail. And in waterfall methodology, if verification fails, there is no going back to implementation. You just stay in verification for quite some time. And depending on the changes that need to be made, this means verification can take a lot longer and be a lot more costly than you might initially expect. So instead, let's think of shifting left and bringing in testing through requirements gathering and throughout the whole project. Testers are great at requirements gathering. They will try and understand the requirements the clients have provided as best as they can, think about how it may actually be implemented in terms of what some possible defects may be and where things aren't quite clear. So they're really good, even just at the very beginning of waterfall. And overall, I would say that testers should just help with every part of waterfall development. In requirements, they're the ones who look at requirements and say, hey, this is unclear, can you clear this up for us? In design, they're the ones who are going to look at it and say, this looks good, but what if there's multiple users, or how many users do we need to accommodate? They're the ones who are going to look at these aspects and really think about them. So that's waterfall. Let's look at another sort of sequential model that is quite popular here in Germany, of the V model. The V model is its own loop, where, let me just show off, where we have our project definition, which will start with the concept of the operation, so getting a bit of understanding of what needs to be done, moving on to requirements and architecture, so the structure, the planning of it, then the detailed design, so essentially some pseudocode, getting a bit more details, and then finally implementation. Once the implementation is done, we move on to the project test and integration phase. So we look at integration, test, and verification of the detailed design. So double check that what's been promised or what's been designed has actually been created in implementation. Similarly, in system verification and validation, we verify that actually, yes, this does meet the requirements and the architecture that was specified earlier in the project. And finally, operation and maintenance should verify and validate the concept of operations that was made at the very beginning. Now, you may already be seeing some issues with this, but let's go over them. So first up, much like the waterfall methodology, the traditional V model brings in testing near the end after the implementation phase. We may do some light testing, but testing is never the focus until we finish implementation. So I would say a good thing to do, similar to waterfall then, we bring the testing in earlier to the non-code aspects. Remember, in vModel, the code only really happens around implementation. And whilst we can test code, sure, we should really look at our non-code aspects too, to help ensure that the software is actually cared for in the whole process. Testers should be part of the detailed design so that they can see if something's wrong before someone actually goes to code it. Testers should be part of requirements so that they can understand, actually, hey, these requirements aren't clear, let's fix these up. And same with concept of operations. So bring them in early. That's the one thing you take away from this little webinar. And finally, let's look at Agile next. Agile, and we're working with sprints. Agile is a flow. We look at short little sprints, normally only a couple weeks long, of design, develop, test, deploy, and review. And Agile is actually pretty good. Agile has testing occur immediately following the development work. This could be small scale on specific features that they are tested immediately after being developed, or this could be large scale imprints of have all the development work done first and then go to test it. And thanks to what we hope is really short sprint cycles, both development and testing already work pretty well together. But I would say we can still bring forward testing into part and just make it part of development. So testing is done throughout development, but we can also think further than that and even bring in testing to the initial planning and requirements. So have testers there at the very beginning to ensure that actually what's being proposed, what's being thought of is actually viable and is clear. Now, we don't need to bring in testers necessarily to communicate with the clients themselves. We could, potentially, but I'd say it's best to make sure that we instead just try and bring them in nice and early. And finally, for our last software development lifecycle, we have prototyping. So prototyping follows a really sort of quick method, kind of like sprints, where we develop, we test, we get some feedback from clients, and then we develop again. So prototyping has the testing occur specifically by the users after the development has completed. Developers will likely test their own aspects of the software that they've created, but really only the end users are actually asked to test the software in traditional prototyping. And hopefully you can already see some little issues here in that end users are great at finding bugs, but they're not testers. They don't know how to properly report defects, and they're not going to find specific defects that are really hard to encounter, but may also be really damaging to the project overall. So instead, I'd say in prototyping, it's probably best to bring in actual software testers. If anything, just to help reduce the burden on finding defects from the users or stakeholders themselves. And so we're already just past 1 o'clock, so we're already hit our 30 minutes for this little webinar. So with that said though, are there any questions in the chat? I'm more than happy to answer anything from today's webinar or just software testing in general. So just give about a minute, see if there's any noise in the chat. Otherwise, I think we can wrap up. Not seeing anything too much. So I may do the outro just now, but if there are any questions that pop up during the outro, I'll be happy to answer them straight away. For now though, if you enjoyed today's webinar and you'd like to know more, I see one from Zabrana, I'll get to you in a sec. If you'd like to know more, then I recommend following us on LinkedIn to keep up to date with us at Go Bigger, as well as what we're currently up to and our future webinars. Chances are you're probably already following us if you're watching this, but why not go ahead, just double check, and plus subscribe to our YouTube channel. Hey, we're hosting these webinars weekly, so it's just 30 minutes of your day, and you get to learn a little bit about software testing. Plus, a like both here and on LinkedIn really helps us out. Helps us more than you could know, and it's a really simple thing that you can do. So, on to Zabrana's question. Have I encountered a situation that someone from testing had to do actual development regarding the whole team approach? I can actually say yes, I have had to do this. I was working in a small project as support and tester, and I have found that developer has made some mistakes in their solution. This was date checking, working with dates. It was a bit of a mess, and they've missed some crucial edge cases so that things just didn't work as expected. So I had to actually go through, perform these changes myself, and then whilst I did test it myself, I didn't write these tests, so we still had that sort of degree of independence. So it doesn't happen, I'd say, all that often that someone from testing has to go into development themselves and fix these things, but it really can. So I hope that answers your question, and I like talking about that aspect too. So it can happen. It probably shouldn't. Let's be real. There may not always be a case where a tester is capable enough to fix these things, and that's why even in the whole team approach, someone shouldn't get in over their heads. But just generally, I think that it can happen. So, if you've enjoyed this webinar and you'd like to know more, then why not go ahead and check us out on our own website with our shop at gobigger/shop. You can check out our currently available courses and see what we're offering in case you want to learn from us and see our expertise firsthand. Currently, we have some courses available on Robot Framework, and as of just a few weeks ago, we have been formally accredited to teach the Robot Framework Certified Professional certification. We don't have an offering for you just yet, we're still ironing out those details, but you can always stay tuned to our monthly newsletter at Grow Bigger. We promise we'll only message you once a month to keep you up to date with what's happening at Go Bigger, and you'll be one of the first to know when we're offering the Robot Framework Certified Professional courses. Plus, you can always follow us on LinkedIn to keep up to date that way too. It's only one click from you, and you'll keep up to date with everything that is Go Bigger. And I've put the links for all of these in the chat. So, for now though, I'd like to thank you all for coming to this little webinar about how to best involve the testing team during development. If there are any further questions, I'm happy to answer those right now, but otherwise, have a fantastic rest of your day, and tune in next week right here for Daniel to discuss how to use Gherkin syntax and write some really good testing scenarios for your team. It sounds really interesting. I'm looking forward to it myself, and hope you are too. Until then, have a great rest of your week, and I'll see you all later. So I'll stick around for a minute if there's any questions, but otherwise, have a great day. Oh, good, Sabrina. Thank you for your question. Okay, I think I'll call it there for the stream. Thank you, everyone, once again. This has been Benjamin Taylor from Go Bigger.